Our sun, which is reasonably hot, sends us a mixture of various rays, which is composed for 10% of UV, 40% of visible light and 50% of infrared. When the incoming solar radiation arrives at the top of the atmosphere, it is directly reflected towards space by clouds and the various layers of the atmosphere. The remainder of this incoming energy is absorbed by the various components of our planet, such as atmosphere, Earth's surface, ocean, etc. Since the Earth's surface is colder than the sun, it radiates heat back to the atmosphere in the form of infrared energy. Most of the emitted infrared radiation is absorbed by the atmosphere and warms it. So, the atmosphere also gains heat and radiates energy both upwards and downwards. The downward radiation is absorbed by the Earth's surface, and the upward radiation is reflected back to space. Nitrogen and oxygen, that form most of the atmosphere, do not absorb the infrared radiation, so they do not contribute to warming the Earth. But the greenhouse gas molecules, mainly carbon dioxide and water vapor, absorb the sun's radiation as infrared. Some goes back into outer space, and most of the energy toward to the Earth's surface. Thus, the greenhouse gas is warming up the atmosphere, and also the Earth's surface, which is called greenhouse effect. In this way, the Earth maintains a stable average temperature. When the concentrations of greenhouse gases increase, then the temperature of the atmosphere also be increased, which leading to the warming of the Earth's surface. Because too much greenhouse gases trap more and more radiations that cannot escape to the space. As a result, radiations remain in our Earth's atmosphere. This causes Earth to warm up. So, the higher concentrations of greenhouse gas responsible for global warming, drought, flood, storm, ice melting, etc. As temperatures rise, glaciers melt faster than they accumulate new snow. When these ice sheets and glaciers melt, the water flows into the oceans, and sea level rise. Sea level rise cause destructive erosion, flooding of wetlands, aquifer, and agricultural soil contamination with salt. Otherwise, rising water level helps to evaporate more water vapors from the warm ocean surface. Hurricane or cyclone get the energy for winds from these warm water vapor and leads to higher wind speeds in the hurricane or cyclone. When carbon dioxide enters the ocean, it combines with seawater to produce carbonic acid, which increases the acidity of the water, lowering its pH. This is called ocean acidification. When water is too warm, corals will expel the algae living in their tissues, causing the coral to turn completely white. Due to drought-induced starvation, many wildlife animals shift their places for searching food and water. Birds also migrate to move from area to another area for their resources. Polar bears are starving because of melting sea ice. They need sea ice to hunt seals as their main source of food. Rising temperatures in the tropics allow mosquitoes to thrive, causing the spread of diseases like dengue fever, Zika, chikungunya, malaria. Heat waves cause people to die of dehydration or heat stroke.
Together, climate change and conflict threaten our ability to live. These crises aren't distinct but intricately interwoven, fueling each other. But what are the threads that weave war and global warming together? And in particular, how do war and conflict change our climate? Militaries use fossil fuels, which duh, everyone does. But is this fossil fuel use really such a big deal? And surprisingly, the answer is yes, it is. Added together, the world's militaries are estimated to be responsible for 5.5% of global greenhouse gas emissions. That covers things like energy for military operations, transport and supply chains for equipment and weapons. As the study behind that stat puts it, if the world's militaries were a country, this figure would mean they have the 4th largest national carbon footprint in the world, greater than that of Russia. For example, burning vegetation, targeting fossil fuel infrastructure, the huge task of delivering humanitarian aid to those who desperately need it. And then after a conflict, of course, there's the energy needed to rebuild what's been lost. For example, in Gaza, the United Nations Office for the Coordination of Humanitarian Affairs reported that after just a few weeks of conflict, the Israeli military assault had destroyed or damaged almost half of Gaza's housing. Wars don't just contribute to climate change through the emissions they cause. War can also be used as a means to gain access to fossil fuels. The invasion of Iraq is a devastating example of this. Many argue that the war was motivated, at least in part, by a desire to secure the country's oil reserves. The war and its consequences have been estimated to have cost at least 100,000 their lives. But conflict also influences climate change indirectly. By fighting each other, we weaken our fight against climate change, and cash is a prime example of this. It's not uncommon to hear from our politicians that we can't afford climate action.
They want to take away your car and put millions of Americans out of work.
This is a nonsense argument anyway, as I've made clear many times on this channel. If we can't afford climate action, what on earth would make you think we can afford climate change? And indeed, a lot of work shows that countries decarbonizing would actually save them huge amounts of money, thanks to stimulating the economy, protecting people from air pollution, and, stopping the climate from changing. But it is true that transitioning away from fossil fuels means spending money up front, and governments hate spending money up front. Except they don't, really. Take the United States, which is a great example because it is both the biggest historical emitter and has the highest military spending of any country. One estimate puts the price tag of decarbonizing the United States at $4.5 trillion. Again, that's ignoring the huge financial benefits which would come from this. So yeah, that is a huge chunk of money. But looked at another way, that's only what the United States spends on defense in around 5 or 6 years. And I think it's a pretty open question which use of money would actually help defend the lives and well-being of Americans better. This isn't just an issue for how countries fight climate change within their own borders. Wealthy nations often bankroll wars waged by other countries. For example, the United States just recently voted a deal that would provide billions of dollars of military aid for Israel. This stands in stark contrast to the weak support that high-income countries offer to combat climate change. Wealthy nations promised lower-income countries $100 billion in climate finance by 2020 and still haven't coughed up the cash about 3 years later. And so, whether at home or abroad, we see how easy it is for countries to open up their wallets for war and how much countries resist paying to protect the planet. It's not all about carbon and cash either. War hurts our climate efforts by halting cooperation too. I feel like it's kind of stating the obvious, but it's already incredibly hard to get the world to come together to fight climate change, with so many competing interests from the biggest emitters to the countries that face the worst climate catastrophes. But when you throw conflicts into the mix, like the current Israel-Hamas conflict or the Russian invasion of Ukraine, tensions soar even further and threaten to derail already fragile deals. And these threats to diplomacy have real consequences. As the International Energy Agency put it in a recent report, there is no low international cooperation route to limit global warming to 1.5 degrees C. How does the heat produced by weapons affect our climate? Let's look at a colossal example, the nuclear bomb that the United States dropped on Hiroshima. This bomb exploded with an energy of 15 kilotons of TNT, just huge amounts of heat produced in that one devastating instant. Look, in so many ways, conflict and war are fueling climate change, whether it's the emissions that they drive, the money they soak up, or the fact that they derail international collaboration. But more and more climate scientists, policymakers, and activists are understanding that these crises are deeply interlinked, and that the fight for climate justice is deeply connected to the fight for peace. I have also been horrified by the Israeli strikes on Gaza, the targeting of civilian infrastructure, and the widespread killing and immense suffering that this has caused. As a Jewish person, it's shocked me to hear people claim that this violence is somehow being carried out in my name, or argue that denouncing this violence is equivalent to anti-Semitism. So it's important that I say clearly that it is absolutely not in my name. I deeply believe that violence cannot be a solution to the suffering, and that we must protect all civilian lives at all costs. And so I absolutely believe we need to fight for a total ceasefire and a return of all hostages. But more than that, we need to fight for a solution that provides long-lasting peace and, crucially, freedom for all people living in the region: Jewish, Christian and Muslim, Israeli and Palestinian. This includes environmental freedoms and justice, such as safe access to land and resources that has so often been denied Palestinians. We also have to overcome the wave of hatred we're seeing rising the world over in the form of anti-Semitism, anti-Muslim and anti-Arab discrimination and violence.
3 degrees. It can be the difference between snow and sleet, wearing a jacket or not. In your day-to-day life, it may not seem significant, but 3 degrees of global warming would be catastrophic.
Heat waves, droughts, extreme precipitation, even fire. 3 degrees of warming is really disastrous.
The scary thing is, the world is well on its way there. Since the Industrial Revolution, the Earth has warmed between 1.1 and 1.3 degrees Celsius.
This is a problem that babies you pass in the street will have to live with.
Children born today are up to 7 times more likely to face extreme weather than their grandparents. If global temperatures do rise by 3 degrees, what would their world look like? Rising sea levels, desertification. Hollywood has always enjoyed imagining the end of the world. While blockbusters like this are clearly fiction, this film will show the scenario we all face, unless more drastic measures are taken to stop burning fossil fuels. A rise of 3 degrees would affect everyone. Even wealthy cities in rich countries wouldn't be immune to the consequences. European capitals like Paris and Berlin would bake under more extreme heat waves. Frequent storm surges in New York could turn parts of the city desolate.
In many ways, cities magnify, intensify climate events. Cities are hotter than the places around them. They tend to be more vulnerable to flooding, and you can get a really bad event in a city in a way that you can't in the countryside.
And because of their denser populations, disasters in a city affect far more people. Some cities might be badly prepared for the changes coming, but they have the means to adapt.
Cities tend to be wealthier than surrounding places. They have a lot of amenities. A city that has taken seriously the risks of a 3-degree world wouldn't necessarily be a worse place to be in a 3-degree world, but a city that hasn't prepared for these sort of eventualities, that might be a really nasty place.
So far, many developed cities have gotten off lightly, but some rural parts of the world are suffering disproportionately. Smallholders, small-scale farmers, are particularly vulnerable to climate change, and there are over 600 million around the world. Smallholders with farms under 2 hectares produce around 1/3 of the global food supply. Migration from Guatemala to the United States has quadrupled since 1990. Not all of this has been due to climate change, but longer droughts would force even more to move. In a 3-degree world, annual rainfall in this region could drop by up to 14%. At 3 degrees, over 1/4 of the world's population could endure extreme droughts for at least a month of the year. Northern Africa could see droughts that last for years at a time. But for some, too much water will be the problem. 10% of the world's population lives on a coastline that's less than 10 meters above sea level. For these coastal inhabitants, a 3-degree world would spell disaster. By 2100, global sea levels could have climbed by 0.5 meter from 2005 levels. Low-lying cities like Lagos would be especially vulnerable, with up to 1/3 of the population displaced. And in Fiji, rising waters are already upending lives. The Philippines and Myanmar are just 2 countries that will also see an increase in storm surges in a 3-degree world. To escape, many will move, often to urban areas. Half the world's population already lives in cities, almost 1/3 in slums. For them, a 3-degree world could be deadly. Dhaka is getting hotter. In the last 20 years, the average daytime temperature has crept up by nearly 0.5 degree. Days that approach 40 are now being reported. And high, so-called wet bulb temperatures are on the rise. A wet bulb temperature is a measure of heat and humidity. Humans cool themselves by sweating. But in these conditions, when relative humidity is near 100%, sweat doesn't evaporate well, so people can't cool down, even if given unlimited shade and water.
At a high wet bulb temperature, the body can't lose heat, and so it gets hotter and hotter, and the body is designed to work at a given temperature, and if it gets too hot inside, you will die.
The human limit for wet bulb temperatures is 35 degrees Celsius, around skin temperature. Dhaka will have a much higher chance of reaching dangerous wet bulb temperatures if global warming reaches 3 degrees.
You can't really adapt to that. You have to get out. If the temperature is so high that you can't work, can't do hard manual labor outside for significant parts of the year, then many places will become functionally no longer part of the economy.
Jacobabad in Pakistan and Ras Al Khaimah in the United Arab Emirates have already recorded deadly wet bulb temperatures. More of the tropics and the Persian Gulf as well as parts of Mexico and the southeastern United States, could all get to this threshold by the end of the century. Climate modeling might show us the weather, but it doesn't show us its other effects on society. Established migration patterns could change. Climate disasters may exacerbate reasons people cross borders. Within countries, more people will move to cities. In a 3-degree world, tens of millions of people a year could be displaced by disasters made worse by climate change.
When people are displaced by climate, they may well go to cities because cities are the places that attract people from the countryside already. A lot of people who can get to the developed world, not least because the developed world tends to be less hot, will give that a go.
As migration around the world increases, there could be more competition for fewer resources. Water, already a highly contested resource, will be a focal point. Turkey's new Ilısu Dam has reduced the flow of water into Iraq. China lays claim to rivers vital to India and Pakistan.
The prospect of a water conflict makes people very uneasy.
China, backward, many China!
How national tensions would exacerbate those sorts of reactions in a 3-degree world is the sort of thing that no one should really want to find out. I think you'd have to be incredibly sanguine not to think that the sort of climate extremes that we talk about in a 3-degree world wouldn't lead some places to the brink of societal collapse.
Those lucky enough to escape unrest would still have to adapt to a radically different world.
People can adapt to climate change in all sorts of ways. One of the most obvious ones is air conditioning. But other ways to adapt at a local or regional level, I mean, one of the most obvious is diversifying agriculture. There are physical things you can do, like seawalls. The fact that people can adapt and that adaptation will reduce suffering doesn't mean that it will eliminate suffering. Suffering is built into this whole process of heating up the planet.
Adaptation will only get the world so far.
The best way to deal with a 3-degree world is not to go to a 3-degree world. And that's why increasing efforts on mitigation are important. It's why working towards negative emissions that could bring down the temperature after it peaks are important. Once you get to a 3-degree world, you are in real, bad, global trouble.
The scale of change needed and the slow progress of governments so far means 3 degrees of warming is uncomfortably likely unless more is done. Despite existing pledges, greenhouse gas emissions are still set to rise by 16% from 2010 levels by 2030. The need to act has never been clearer. There's still time to reduce emissions so that a 3-degree world remains fiction rather than becoming fact.